So this is something that's going to be a little crazy to wrap your head around at first, but we're actually going to derive the time travel equation or formula. And to do that, it just involves a little bit of fancy algebra. So let's get going here. So it's going to be expressed as a right triangle. So let's define first our variables here. Well, c is our speed of light constant. T is going to be the time on Earth. This T sub zero kind of thing is the time on some object. So the time on something. And then v is going to be the speed of that something. So let's actually start deriving the formula. So whenever we see a right triangle, what do we think of? Pythagorean theorem should kind of ring a bell. So let's write that down. So we know the Pythagorean theorem is, I'll do it up here, a squared plus b squared equals c squared. So this can be a, this can be b, and this can be c. Well, it has to be c, it's the hypotenuse. So, alright. So this is just kind of a plug-in, and then, like I said, fancy algebra kind of thing to solve for t. So I'll start down here and work my way over, because it's kind of a long process. Alright, so our a term is, we're going to have vt quantity squared plus our b term, which is c times t sub 0 kind of squared. Our c term is ct squared. Okay, so let's just distribute the squared out. So this is going to give us v squared t squared plus c squared t0 squared equaling c squared t squared. Okay, so we're solving for t, not t sub 0. So don't get those mixed up, first of all. And what we're going to want to do is whenever we solve for something, we want to get it all on the same side. So let's take v squared t squared and move that over to the right side. And that's going to leave us with, let's see, c squared t0 squared equals c squared t squared minus v squared t squared. Alright, well, now we're like, what do we do? So over on the right side, we have a common term. And when we see a common term on one side, we should think factoring. And hopefully you know how to factor, but I'll briefly go over it. It's not too difficult. It's basically just find the greatest common factor, pull it out, and then if you redistribute that factor, you should get what you originally had. So I'll go ahead and show that now. So our left side stays the same. Alright, so if we take a t squared out, we're going to be left with c squared minus v squared. Because think about it, if we redistribute this, what are we going to get? We're going to get c squared times t squared minus the v squared times the t squared. So that's basically all that is. It's not anything crazy difficult. Okay, so now what we're going to want to do is divide this thing in parentheses here that we just factored, and that way we can isolate t. So I'll move up here now. So let's see, we're left with t squared equals c squared t0 squared over this business, v squared. Alright, so let's see what we can do. Alright, so there's a number of ways you can simplify this, but we want to do it the way Einstein did it. So to do that, we're going to do a little, kind of make an abstract move that you wouldn't really normally think of doing, but there's a reason behind it, and I'll explain why later. So what we're going to do is factor a c squared out of this denominator, because what that's going to allow us to do is cancel the c out. So you'll see what I mean after we go a little further with the math here. So let's see, we're going to get t squared equals c squared t0 squared all over, and we're going to pull that c squared out. So we're left with, let's see, 1 minus v squared over c squared. Like before, if we redistributed this, we're going to get our original. because these are cross products over here. So c squared over 1 times this thing right here is just going to give us v squared, which is what we have up here. So that's all good right there. All right, now this equals, let's see. So now we have t squared equals, and the purpose of factoring this, like I said, was we could cancel out these terms right here. So now we just have t sub 0 squared over 1 minus v squared over c squared. Alright, so things are looking good. They're kind of falling into place. So now let's take the square root of both sides to just make that t, and then we're going to have our formula. So we're going to have t equals, well, the square root of t sub 0 squared is just t sub 0. Alright, and then we're going to have, this is where it gets kind of strange. We want to leave this as a radical. Now some of you might be saying, well, there's a radical in the denominator, we can't have that, it's irrational, whatever, but there's a purpose behind it, and you'll see why I'll do another video where I actually do an example, and that'll really hit the point home of why it can be done this way. So, and I'm showing this to you just for the sake of an exam where you might need to show derivation. So, anyway, let's move forward. So, v squared over c squared, and yeah, this is our formula right here. This is our time travel formula. So like I said, I'll show an example in another video, but the reason why we kind of did this weird factoring over here is because if we have a problem, for v, they're gonna tell you, well, an object moves at, or you're moving at like 99% the speed of light. So you're gonna have 0.9, the way you express that is 0.99 c. So 0.99 times the speed of light. And when you plug in 0.99 c for v, you're going to have 0.99 c squared over c squared. So what's that going to give you? You're going to have c squared over c squared, and c is going to cancel out. And then it's essentially just plug this whole business right here in your calculator, and there's your answer. So hope this helps.